massive asteroid from outer space heads straight for Earth. It's as large as the one that impacted over 4 billion years ago. This computer simulation has been made with the scientific advice of geophysical experts to show the effects if the impact were to happen today. The asteroid's diameter is larger than the main island of Japan. Even though it is moving at over 720,000 kilometers an hour, that's almost 450,000 miles an hour, the asteroid appears eerily slow because of its size. The actual impact happens in the Pacific Ocean, just under 1,000 miles south of Japan. The crust of the Earth is peeled away like an orange skin by what is called the crest tsunami. Even the deepest part of the Pacific Ocean looks like a thin film. Huge chunks of debris the size of city blocks are hurled into the air. The entire Japanese archipelago is disintegrated, as is some of the Asian continent. The shattered remains are hurled out into space way beyond the atmosphere to bombard the Earth with deadly intent when they re-enter. At 7,000 meters, 23,000 feet, the rim of the crater is higher than many mountains on Earth today. The size of the crater would be a distance of 2,500 miles or 4,000 kilometers. And this is just the start. NASA has the world's largest collision test machine used to try and find out what would happen after the moment of impact.
Okay.
Dr. Peter Schultz fills a small tank with water to see how the ocean would react. The actual impact object is tiny, but it will hit the water at a speed 20 times faster than a bullet fired from a pistol.
Oh, gorgeous. Joe, that is gorgeous.
Just one tiny aluminum bullet had this result. But the impact which created mayhem is not the entire story. To get the full picture, the moment of impact has been slowed down so that 1 second seems to last an eternity. At the moment of impact, it is like slamming the brakes on. The kinetic energy of the bullet is transformed into heat. White smoke rises. It may look like a splash, but it is actually water vapor. The heat vaporizes the water in an instant. And heat has a deadly potential.
When an asteroid hits the surface of the Earth, the material is heated up to temperatures that get up to the point of, say, 4,000 to 6,000 degrees centigrade. This is as hot as the surface of the sun.
Moments after the impact, rock vapor, the temperature of the sun, begins to engulf the world. Could any life at all survive this impact? Immediately after the impact, the rock vapor rises up from the crater in a dome, then spreads out in all directions across the globe. 3 hours after the impact south of Japan, the expanding wall of vaporized rock reaches the mountains of the Himalayas. The perpetual snows are instantly evaporated. Soon the wall of fire reaches the Amazon, the furthest distance from the point of impact. The forest spontaneously combusts even before the rock vapor arrives. Just 1 day after the impact, the entire planet is covered. Every living plant or creature is vaporized. It's been estimated that this vapor would cover the entire globe for almost a year. It would be as if the sun had come to Earth. The ocean would start to bubble and boil. And as the water evaporates, the oceans would drop at the rate of 5 centimeters or 2 inches every second. Even the salt deposited on the ocean floor vaporizes, and then the very bottom of the sea melts. Nothing is left untouched. One month after the impact, the surface of the world has been sterilized. The oceans have vanished. All that remains is the superheated bedrock. It is thought that an impact like this happened 6 times in the violent past of the Earth's history. If there was life, it was assumed that it too would have been wiped out, only to begin again. Immediately after the impact, the planet would have looked like a fireball. But within only a year, the rock vapor would start to dissipate and temperatures would begin to drop. Because of the Earth's size and gravity, the evaporated water would not escape into space, and within only 1,000 years, the water vapor would cool and condense, and then fall back as torrential rain. Once again, the oceans would start to fill. The rainfall would be as heavy as tropical rain is today, and in only 3,000 years, the oceans would have regained their original depth. The stage was set for life to return from the deep.